right, so when we're naming acids for the hydrochloric acid, for example, if we have to go back and write the formula for hydrochloric acid, do you guys, do you remember the way that I kind of had helped you out? Need a little refresher on the scheme there? All right, so if you have hydro and then ic, and I told you I remember like the fancy way of saying the water cycle hydrologic, but anyway, if you had to have a hydro and ic, remember that was two things? So the acid is probably only made out of two ions. So hydrochloric acid is only made out of, and when I say two ions, I should say two compounds, like two elements. That's what I'm getting at. So if I only, hey, want to have, they're in the lab,
Okay.
going over some books. If I only want to have hydrogen and one other thing, and this is hydrochloric acid, should I break out a polyatomic ion at this point with oxygen in it? No. So if you see hydro and ic, it's probably H, and then something from the periodic table. Now, hydrogen is 1 plus, and chlorine is 1 minus. So you do have to, with the acids, you have to do this. And so what I should have done, I'm learning, I've joined this like teacher thing, and I'm learning about these little circles and how helpful they are. So if that's hydrogen and, you know, this is chlorine, and if we look at the charges for those, this is 1 plus and this is 1 minus. Are my charges going to neutralize? Yeah, and so I think when I teach this next time, instead of making like lines, I'm just going to draw circles, and that's 1 hydrogen, 1 chlorine, charges balance, 1 of each done. So that's that one. I feel like I should have done the circles to start with, and if I messed you up, I'm sorry. All right, so why don't we do all the acids? So phosphorus acid. And so if it ends in us, I think about senioritis. Senioritis. So if that, what does the acid have to have at the beginning? What's the first element? Oh, sure, hydrogen. So senioritis. So this is phosphorus acid. So what was the polyatomic ion if it turned to us? Phosphite. See how I'm doing that? So y'all know the formula for phosphite. If you don't, that is a problem. Phosphate's PO4 3 minus, so phosphite is PO3 3 minus. So if I come over here and I get my little circle drawn on, and so here's my hydrogen, and you know, here's my phosphite. 1 hydrogen is 1 plus, right? And then if I do I don't know, pick a different color. 1 phosphate, or excuse me, phosphite. The charge on that phosphite, that 1 phosphite, has 3 minus signs. Oh, Lord help me. I'm gonna have to figure this out. Can you tell? So, are my charges balanced? No. So, do I need to add another phosphite or another hydrogen? Okay, sure. So, let me do that. Are my charges balanced out? So I need another hydrogen. And I'm gonna have to like play around with the color scheme. You know, I'll find like the fastest ones. But so I have to have 3 hydrogens and 1 phosphite. So with acids, starts with the H. And you have to make sure that you have to balance the charges out. All right, any more acids up here? Sulfuric acid. So the trick for naming the ick is if you ate an acid, it would be icky. All right, now, it doesn't have hydro, right? So it's not one of those things where I have just hydrogen and one other thing. So if you ate acid, it would be icky, and this is sulfuric acid. And so what do I need? So it's in an ick. What polyatomic ion do I need to have? See, I'm figuring that out. So I need hydrogen, and I need sulfate. I'm not going to leave it like this. I have to come back and fix this. So, let me try this one. So I have one hydrogen and I have one sulfate. And if I go back and I put my charges in, is that neutral? What I need more of? Okay, and so how many hydrogens? Is that enough? Okay, so now when I go write my formula and I make it neutral, I have H2. Do you like the circles better than the chart? Yes. Sorry, you get better every day, right? So that's how to do that. Now let's go down to the bottom and do the acids. So is the 11 an acid? 12 acid? 11's not. What about 12? Yes. Absolutely. So 12 is an acid. Let's think about what we have here. We have H3PO4. What is this polyatomic ion? What's this name? Phosphate. There, I fixed it. So if you ate an acid, it would be icky. Right, and do I need the hydro? No, because I have all of this mess. So hydrophosphoric acid would be H3P, done. So if it's, as soon as you have the oxygen, it's not hydro anymore. Exactly right. And so this is phosphoric acid.
So for number 16, H2S, it would be hydrosulfurous acid.
Hydrosulfuric, and that's where that hydrologic thing comes in. You got to think about the water cycle. You put hydro in it. So yeah, good. So the next acid is 16. So this only has 2 elements, so I have to do 2 things to it: hydro and ic. And so I'm going to put sulfuric in there. Did you see how I did that? Okay. So this way is easier. So 17, what is that an acid? Does it start with an H?
Yeah.
Then it's an acid. Done. Okay. So anyway, what's that polyatomic ion right there?
Chloride.
That's exactly right. Chloride. And so this is chloride. And senior itis, right? So what does it not need to be now? Chlorous acid. Not so bad. You saw you have to kind of break it down.
Yeah.
18 is it an acid?
Yeah.
Does it start with H? Sure. And so on 18, it's made of 2 things only. So I have to do 2 things to it. So hydro iodic acid. So, when we're the rest of the semester, you're not going to just have a bunch of naming. You're going to have chemical reactions. But it would be good if you had a plan. Like, oh, this is an acid. Yes, let me do the things. So that's fine. And when you retake this tomorrow, I would really recommend that. Go through all your acids, and then you might do one wrong, and then you go to the next part and you go, oh, okay, I messed that up. But if you're just mixing them all up, I think that doesn't help. All right, so let's do all the covalent ones. So looking through for the covalents. Hey, where did we doing that? Naming. I taped it so you can go back and watch it.
Okay, thank
Cool.
you so much.
So let's look for a covalent. I didn't do a lot of these. So what's the first covalent one you see? Do you need a copy of the quiz?
That'd be awesome.
Here you go. No problem. So the first one I see is silver, a nonmetal. So when you're looking for covalent, you're looking for all nonmetals. And no ionic compounds, no polyatomic ions. 7. So carbon tetrachloride. So with these, it doesn't have a prefix, so it's just 1. The first one, remember, doesn't get a mono, right? And then chloride is tetra. Tetra is 4. Some people miss questions on the quiz because they didn't know the difference, like tetra and penta and all that. So if you don't know your prefixes, get that down for sure. So that is really straightforward. The next covalent, which was the next one y'all see? 9, sure. Okay, so I know I have sulfur, and I know I have fluorine. Tri means what? And then hex is 6. All right, this is going okay. 11 is 11 covalent.
Yeah.
No, it's not. Let me tell you why. It's not covalent because you have ammonium. So when you see a polyatomic ion, it's when you see a polyatomic ion, it's ionic. So that's the trick on that one. And so 12 is an acid. We already did all of our acids. Acids will trick you because they'll contain all nonmetals. That's why you need to do them first. So I told everybody before we came in, Lucy, I had told them to do all the acids first and then get them knocked out. So then you won't mix them up. Now 13, is that covalent? All right, so I have, how many borons do I have? All right, so what do I need to put in front of boron? Diboron, tri. Yeah, so no big deal, right? Okay, 14 and 15, do those have metals in them? 16's an acid, 17's an acid, 18's an acid, 19 got a metal in it? No. So, do I need a prefix in front of the oxygen? So, oxygen, and then what's the prefix for 5? Pentafluoride. And then is 12, is it covalent? No, it's got copper. Copper's the metal. So, that takes care of those. Bottom line to me, like the covalents are gifties. Alright, so at least get those. Now let's go back and do the other ionic ones. And I'll use the charts again. So, for manganese, oops, that looks really icky. The manganese for sulfide. And I have to write the formula for it. I still messed up there. So manganese 4 sulfide. What does the Roman numeral tell y'all? What's the Roman numeral? It's not how many you have, it's the charge, right? So I have manganese, and each manganese is 4+. And what's the charge on sulfur? If it ends in "ide," I'd look on the periodic table for it. Did you catch me? If it ends in "ide," I'd look on the periodic table. So what's the charge of sulfur? Do y'all feel comfortable looking at the periodic table and telling the charge?
3 minus. No, 2 minus.
Yeah, so you just count how many spaces over it is to get to the noble gases, but it is 2. So it's 2 minus. So what I was showing them earlier, 1 manganese is 4+, and then 1 sulfur is 2 minus. Is this neutral? No. So, do I need more manganese? No. Which one do I need more of? Cool. Now is it neutral? So, when I go to write the formula for this compound, manganese 4 sulfide, do I need a subscript on this manganese?
No.
What was my subscript on the sulfur?
2.
Done. Okay. So, let's do, we already did 3, we did 4. Silver carbonate. Now, I told y'all that silver was always been plus, but some people still mess this up. So, anyway, I don't know if I confused you. So, silver carbonate. So, what is the charge always on silver, you guys? Yeah. Okay, so let's start with 1 atom or ion of each. So there's 1 silver, and there's 1 carbonate. 1 plus 2 minus. Is this neutral?
No.
No. So what do I need more of? Silver or carbonate? Sure. Now it's neutral. So when I go to write my formula, I have silver and I have carbonate. What do I need to do with my subscripts here? Which one Do I need something on the silver here?
Yes.
What do I need? Okay. And carbonate is fine because I just have one of them. You don't need parentheses on the polyatomic ions when there's just one. It's like, okay.
It's most likely, yeah.
Yeah.
So the one that needs the subscript is the one that you add.
Yeah. And so if I had put another silver here, then, I would put a 3 here. Exactly. So let's do a couple more of these. So let's look. The next one on the list is aluminum acetate. So I have aluminum and I have acetate. What's the charge on acetate? 1 minus. And what's the charge on aluminum as an ion? It's on the periodic table.
4. No, 3 4.
It's 3 plus. All right, so let's get some ions drawn up here. And get a carbonate. I think that's a little too big. I'm practicing. Y'all are my test group. Thank you. So each aluminum is 3 plus, and each acetate is 1 minus. Is this neutral? No. Let me see if I can. Is this neutral? No. Is this neutral? Yeah, so when I go to write my formula, do I need a subscript on the aluminum? No. Do I need one on the oops, that's not carbonate. We just did carbonates. So how many acetates did I use?
3.
3. So I need parentheses. And then I'm going to put a 3 down. So when you have more than one of a polyatomic ion, you need parentheses.
Right, so that doesn't get confused with the subscripts of the actual.
Right. Now, if I was just to put a 3 right here, it looked like I had 23 oxygens. And you'll appreciate that a little bit more today as we go into balancing equations a little bit more. So, moving on. Carbon, we did that already. Hydrogen, iron 3 hydroxide. Let's do that one then. So I have iron 3 hydroxide. What does that Roman numeral tell me? Sure. So that 1 iron is 3 plus. And then what's the formula for hydroxide?
OH minus.
1 minus. Don't flip those letters around. Alright, so let's draw these in. Let's start with 1 ion of each and see where we are. So there's 1 iron and there's 1 hydroxide. And so in that 1 iron, my charge is 3 plus. And in this 1 hydroxide, the charge is 1 minus. Now, are my charges neutral? No. So, do I need more iron or do I need more hydroxide? Sure. So let's add another one and see where we are. Is that okay?
No.
No? So maybe one more, huh? How's that? Happy times? Okay, so let's go ahead and write it out. Iron, and there's my hydroxide. Does the iron need a subscript?
No.
No. What about the hydroxide?
3.
Can I just put a 3 right here? What about right here?
It has to be parentheses.
Yes. Ta-da. If I was to leave the parentheses off, it would look like I had 3 hydrogens and only 1 oxygen. So that's the issue. It's like in math class if we were distributing, right? You want to, okay, I have 3 of all of this. Okay, so next is we have calcium cyanide. So calcium is, what's the charge on calcium? 2 plus, good. And then what is the formula for cyanide?
CN.
That's exactly right, CN minus. So let's start with 1 ion of each. So each calcium ion has a 2 plus charge, and each cyanide ion has a 1 minus charge. So is this a neutral compound if I have one of each?
No.
No. So of course it's neat.
Which one do I need more of?
Yeah. I heard you, but I just wanted to make sure. Alright, so how about this? Is this neutral?
Yes.
Sure. Okay. So I'm going to write calcium and then cyanide, and now I'm going to write, yes, and then a 2. Okay. Moving on. I feel like going from the compound to the name for ionic is pretty straightforward. So let's take a look at the list that we have. When you're looking from the formula to go to the name for ionic, you need to check to see if it's in the D block, and or if it's lead, or if it is antimony, because those two will give you trouble. So anyway, going down, cobalt and sulfate. So number 14, that compound there, is cobalt in the D block. Yeah, it is. So with this one here, I don't know the charge of cobalt. I have no idea. Right? That's the issue. And then I know the charge of sulfate. Now, if I'm going to draw my ions up here, how many cobalts am I going to draw? Look at your formula. Just one. Can I draw 3, 4 cobalt? No, I can only draw one. And then how many sulfates do I draw? How many?
Oh, wait.
2. Look at the formula. What is the formula for sulfate? SO4 2 minus. How many? If this is my formula, how many cobalts do I have? How many sulfates do I have? 1. Is there parentheses around this?
Oh.
I love it. So I have 1, and how many sulfates do I have? 1. So how many circles do I need to draw? All right, now we have to think backwards on this a little bit, okay? That was great. I know that this 1 sulfate has 2 minus charge. So I know that I only have 1 cobalt. Do you understand why I know that I only have 1 cobalt?
Yes.
What has to be the charge of that 1 cobalt? It has to make a neutral compound. And that's how you can tell. So when I go to name this, I'm going to name it. Can I just name it cobalt sulfate? No, so I need Roman numerals. And what's going to, 1, is that enough? 2, right. Cobalt 2 sulfate. I feel like I saw some light bulbs on that one. What about lead? Is lead one of the ones that we need to be concerned about? Yeah. So let's look at this formula. So I have lead, and then I see that it is bonded to a carbonate. So I just can't call this lead carbonate because lead can have more than 1 oxidation number or charge. So anyway, I know that I have a lead, and I don't know the charge, and I know that I have carbonate. Now, what's the formula for carbonate? CO3 and then what? 2 minus, that's right. So looking at this formula, how many leads do I have? Okay, so I'm going to go ahead and draw that in. How many carbonates do I have? Okay, and what is this charge on this 1 carbonate? And do I know the lead to start with? That's the issue, right? That's the whole issue. So if I have 1 lead, 1 carbonate, and this carbonate's 2 minus, what has to be the charge on this 1 lead? So now I'm going to go and I'm going to name it. So I'm going to say lead. Now what do I need to do? Yeah. 2 carbonate. Okay, so looking at the other ones that we have, the only other one that I see is number 12. And so I have, why don't we just pretend that this is, oh, I messed up. I'm trying to give you something tricky. I did a bad job. let's just change this formula that we have written, and let's write it like this instead. Okay, so let's just see that we have 1 copper, and then it's bonded to perchlorate, but 2 perchlorates. So I have copper, and I have perchlorate. Now, what do you already know the charge of perchlorate?
Yeah, that's mine.
It's just 1 minus, right? So, looking at this formula, how many coppers do I have?
One.
Just 1, okay? How many perchlorates do I have? Okay. All right. So, when I go to add the charge to this, what can I put in these 2 ions?
Ebony Callahan and Miranda Thomas.
So, what has to be the charge of that 1 copper? How many?
Oh, no, 2.
Do you see how I figured that out?
Yeah.
So now when I go to name it, it's copper 2 perchlorate. And there you are. So take a look at this, and we'll give this a retry tomorrow. If you want to, why don't you guys, my planning period is next period. Why don't you guys come back after 3rd if you can?